over at 1,4, you're still solving equations. They're just absolute value equations. So first, who knows what absolute value is? What does it mean, absolute value? Somebody has to know what.
Like your size don't matter.
That's true, but why is that? Right. Absolute value is the number's distance from 0 on a number line. So since it represents a distance, it can't be negative. And that's what she was saying about the signs. It doesn't matter, it always has to be positive. Okay, you cannot have a negative absolute value. You can't live -3 miles from the school, right? Distance has to be positive. That's why it always is. So if you had 2 and -2 on a number line, they both have a distance of 0 and 2. The distance between -2 and 0 is 2, same as +2. That's why it's always positive, representing how far from 0 it is. So the first problems in the section, you're just going to be plugging in numbers and simplifying like we did back in section 1. We won't spend much time on those. Plus the absolute value of 5x minus 7. That's it. So it's not even an equation, it's just another expression. And it tells you x equals -3. So you're going to plug that number in. So absolute value works like a grouping symbol as well. You're going to simplify inside there as much as you can. Make sure you have your absolute value bars a little bit longer than a 1, so you don't confuse yourself there. So we have -15 minus 7 in our absolute value, which would give us what? What? Minus 7. -22. Now, you've simplified that as much as you can. You can't change any more inside there. So what is the absolute value of -22? 22. So you just change that to positive 22. What if it had been the absolute value of 22? It's still 22. You don't change that. Even if it's positive, you don't make it negative. It's not making the opposite, it's just making it positive. So our final answer then, 23.4. Be careful if you have a situation like this. What's the absolute value of -3? 3, but that negative out there stays out there, so it still looks like -3. This is not -3, but with the negative out front of it. You'll probably have that in some of your problems, so watch out for it. So the other thing is solving the absolute value equations. There's one step you must do in order to get these right. Since absolute value can be to the left or the right of 0, you've got to change them a little bit when you solve the equation. So if you have the absolute value of x minus 18 equals 5. Well, the absolute value of this can be 2 places. It can be to the left of 0 or the right of 0. Okay? Anytime you have an absolute value equation, you've got to write that out 2 ways. You write it exactly as it is. That's for the right side, the positive side. And then you also have to solve it for the negative side. Since its absolute value can be either 1 plus or minus 5. Notice once you split it up, you no longer have the absolute value in there. That gets rid of the absolute value when you write it out twice. So don't have that in there anymore. That'll just confuse you. Now they're just two very simple equations like the ones we just solved. And you're going to do the same step here. What are we going to do to that? Well, it's negative, so you're going to add the 18. So x equals what? 23. You're going to do the same step over here, add 18, but your answer is going to be different. What? 13. So you get two answers. That's the only difference in this section. You have to split it into two since it's absolute value. Okay? One other thing that will happen. Absolute value of 4x plus 1 plus 8 equals 2. Here's another rule. You cannot split that up into the two things until the absolute value is the only thing on one side. So first you've got to move the 8 in this case. This has to be by itself before you split it up. So how would we move the 8 over? Subtract the 8. So we have absolute value of 4x plus 1 equals what? Negative 6. Can absolute value be negative? No. We already said absolute value cannot be negative. Doesn't that say that the absolute value of that equals a negative number? Yes, it does, which is not possible. That's a no solution. The absolute value cannot equal a negative number. If it does, you got to see. Those are the ones we hope for, right? You hope you see that a lot, so you can just put no solution and move on. So watch out for that case. Make sure you don't split that up. Up here, when you had it set equal to a negative, we no longer had the absolute value. Okay? So if you end up with that, or anything close to that, you can't do it. Absolute value of x plus 6 equals 3x minus 2. We won't do very many of these, but I want you to know how to do them. So is the absolute value by itself on this side? Yeah. So you're going to split it up. X plus 6 equals 3x minus 2. We wrote it exactly as it was, and then you've got to make it negative. So, negative quantity 3x minus 2. You've got to have them both. Notice there's no absolute value in there anymore. And then you just solve it. We didn't do any examples where you have x's on both sides, and I had a couple questions about that, so we'll go over this example. If you have x's on both sides, you've got to move either the 3x over with this x, or move the 1x over to the 3x. Doesn't matter which, but your x's have to be on one side. Maybe it's helpful for some of you to draw that line. So if we subtract this x over, that's gone, we're left with 6. What do we got there now? 3x minus x. It'll be 2x minus 2. Now we just have this x. So we got to get rid of these 2's. So we add the 2. Eight equals 2x. What do we do there? Divided by 2. So 4 equals x. That's one of our answers. And then you got to come over here and solve. What do we need to do there first step? Distribute that negative in there. Change those signs. So we have x plus 6 equals negative 3x plus 2. So we distribute that negative 1 inside there. Changing the sign. And you just solve like we did the other side. So we move that x over again. This time, though, what do we have here? Negative 4x. So we move the 2 to the other side. And what's our last step there? Divide by negative 4. And we get negative. When you solve these kind, where it's not set equal to just a number over here, you need to check both of your answers. You can plug them back into the original problem and see what you get. So if we plug 4 in here, what are we going to get? 10. And when you check, you don't really have to show all your work. Just plug it back in. Make sure they are answers. And on the other side, what are you going to get? 3 times 4 would be 12 minus 2 is 10. So 4 checks out. So you need to check negative 1. If you put negative 1 in there, what are you going to get? Negative 1 plus 6. What? Somebody said 5. You got 5 on this side. You put negative 1 in there, what are you going to get? You have negative 3 here, and then minus 2 will be negative 5. That's not correct. So x equals negative 1 is not an actual answer. A lot of times in algebra 2, you will have to check. In algebra 1, you check just to see if your answer is right. In algebra 2, you have to check because sometimes you get answers that really aren't answers. And you got to write that down. So if you have both of these listed as answers, it's not right. Check and see which one was the final answer. Problems for this section. You only have the 2 things to do. You're either just going to plug it in and evaluate, or you're going to solve. So we just have 2 types of problems. Do 16 through 32. Even and 36 through 44 even.